This is section 6-2, and we're going to look at graphs of functions and determine if a function is going to be even or odd. And so today we're going to identify zeros and determine even and odd functions. Now the zeros of a function f are the solutions to the equation f of x equals 0. In other words, x is a zero of f if and only if this point x0 is an x-intercept of the graph. So x-intercepts are zeros of a function. They are synonymous with each other. So just know that if you ever see this phrase, find the zeros of a function, it's asking for the x-intercepts. Now, to determine if a function is even or odd, we're going to look at symmetry. Now, we've looked at symmetry in terms of points. We've looked at symmetry in terms of equations. And now we're looking at symmetry in terms of functions. And so a function is symmetric about the y-axis if and only if this statement is true. If f of negative x equals f of x. We can say that it's symmetric about the origin if and only if this statement is true. F of negative x equals negative f of x. Now, until we really talk about polynomials, we call the function even, so this function would be even because it's symmetric about the y-axis. And then we call this function odd if it's symmetric about the origin. So now let's determine analytically if the following functions are even, odd, or neither, and verify the result with a graphing calculator. So we'll take a look at what it looks like graphically. So we know if it's even if it's symmetric about the y-axis. So let's determine that. Is f of negative x, does that equal f of x? So my f of negative x means I got to plug in a negative x into my function. And then my f of x is just 5 over 2 minus x squared. So my f of negative x means my input is negative x. My function f of x, which is this, is just what I have written there. So now simplifying this, and this, if I square that, that's going to give me 2 minus x squared, which equals 5 over 2 minus x squared. So because they're both equal, I can say that my function is going to be even. Now let's just test for fun if it's going to be odd or not. So let's take a look at that. So that means f of negative x, does that equal negative f of x? So once again, I get 5 over 2 minus negative x squared, and we said that that's 5 over 2 minus x squared. Now on this side, negative f of x. So there's just a negative in front of that, which is not equal because I have negative 5 over 2 minus x squared. Now graphically, so this function's only even. So graphically, this is what the graph is going to look like, and if you notice, there's my y-axis, and so it's perfectly symmetric over it. If it folds that way, it's perfectly symmetric. If it folds that way, it's perfectly symmetric. Now if I wanted to find zeros of this function, I would take my function. We said f of x has to equal 0. So I'd take my function and set it equal to 0, and then I solve for it from there. So that I multiply both sides by 2 minus x squared, and then I get 5 equals 0. Well, that's an improper statement, so there are no zeros. Now to even verify that, if we look at the graph that I have here, if you notice, it's not crossing the x-axis here, right? This is an asymptote. It's just getting closer and closer, but it's not crossing it. Let's look at this next one. So to see if it's going to be even, we said the definition says it has to be f of negative x, does that equal f of x? So now simplifying that, I get 5 times negative x over 2 minus negative x cubed. Does that equal 5x over 2 minus x cubed? So now simplifying this, I get negative 5x over 2, now negative, because there's 3 of them, negative, 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 that's going to still be negative, so negative, negative is a positive. Well, those do not equal each other. So because those don't equal each other, therefore it's not even. So now let's try to see if this is going to be odd. So if we have f of negative x, does that equal negative f of x? So f of negative x, so that's going to be still we said that that's going to be negative 5x over 2 plus x cubed. Now if you're wondering, wait, why did I write that? Well, we said this was f of negative x already, so this is it already simplified. So I just rewrote that already simplified. So now does that equal negative f of x? So now simplifying this, I'm going to get negative 5x over 2 plus x cubed. Does that equal negative 5x over 2 minus x cubed? Now the thing here is, because this is a plus and this is a negative, they're not the same. So it's going to be neither. They're not odd and it's not even. Now let's take a look at this graphically. Now if you notice here, it's definitely not symmetric over the y, because if that folds over, it's not the same. And it's also not odd because if this flips over the x-axis and flips over again, they're not going to be the same either. So it's definitely not about the origin. Now let's test for zeros. So 5x over 2 minus x cubed, set that equal to 0. Multiply both sides by the 2 minus x cubed. And so 5x equals 0, divide both sides by 5, x equals 0. And so there are my zeros. Example number 3. Let's determine if this is going to be even or odd. So for this one here, if I enter it into my function, does f of negative x, does that equal f of x? And so entering that in here, I'm going to get 5 times negative x over 2 minus negative x squared. Does that equal 5x over 2 minus x squared? So now simplifying this, I get negative 5x over 2 minus x squared. And so because this one has a negative, this one doesn't, it's not going to be even. But now let's test to see if it's odd. So I have negative 5x over 2 minus x squared. And so if I plug in a negative, I get negative 5. Oops. So that's just going to be 5 over 2 minus x squared. And so distributing that negative through, I'm going to get negative 5x over 2 minus x squared. Those are equal. This is the same as this, and so therefore it's going to be odd. Let's take a look at that graphically. And so notice over the origin, if this gets reflected and reflected, it becomes here. If this gets reflected, reflected, it's going to give me that. And so I can definitely say that this function is going to be odd. Now for this graph here, we just want to be a little careful. If I wanted to determine if this was going to be even, that means f of negative x equals f of x. So plugging that in, I get 5 times negative x over 2 times negative x minus negative x cubed. Does that equal 5x over 2x minus x cubed? So I'm going to get negative 5x on top, and on the bottom here I'm going to get negative 2x. Negative negative is a positive, so plus x cubed. And I know sometimes we may think and look at these, oh, they're not the same, but what if I factor out a negative out of the bottom? That means that those will cancel out, and if you notice, that's now 5x over 2x minus x cubed. Those are the same. So therefore, my function is going to be even. I'm not going to even test to see if it's odd, because it's not. And so if we notice there, we get this graph here, and it is even over that line there. Now for this one, one thing that we should look at if we were to test it, we would get both if we test if it was even, and if it was tested as odd, it would say neither, okay, because it's not going to be even or odd. But if we looked at the graph here, it looks like this should be even, right? I mean, if I draw this and this is symmetric, it looks like it's going to be even, but it's not. And the reason is it's just how we're zoomed out. Because it's zoomed out this much, it doesn't look like it's going to be even. But if you were to actually like zoom in on this lens, you would notice that this graph here is shifted over a little bit more than it should be, and so it's not perfectly symmetrical over the y-axis. And so that's why it's not going to be even or odd. And for this last one here, to take a look at this one, for piecewise, what we want to do is you want to determine if equation number 1, applying the transformation, translates into equation number 2. So we can look at this visually and we can look, okay, yeah, it looks like this is going to be even because it's symmetric over the y-axis, not over the origin, because if that gets flipped and flipped, it's not going to be the same thing. So testing this, we said, is my f of negative x, is that going to equal f of x? So my equation in number 1, that's going to be negative x plus 3. So that was my equation from number 1. And then so what is the f of x from equation number 2? That's going to be negative x plus 3, and so negative x plus 3 equals negative x plus 3, so we're good there. And so now we want to take a look, is it going to be from the other side? Equation number 2 as it goes to equation number 1. So if I do that, well, from equation number 2, this will give me negative x plus 3. Does that equal x plus 3? And I got this from equation number 1. And so, yes, x plus 3 equals x plus 3. And so I can say that my function's even. Now, if you were to do this for odd, let's test to see if it's odd. So equation number 1, as it translates to equation number 2, we know that it's going to be f of negative x. Does that equal negative f of x? So for equation number 1, we have negative x plus 3. Right, my input is that. Does that equal the negative? Now it's the function from number 2. Well, if I distribute that negative, this becomes negative x plus 3. I get negative x minus 3. Those are not the same, and so because they're not the same, it's not going to be odd. And so it's only even. In closing of today's lesson, what did we learn today? Well, we talked about zeros and how an x-intercept is the same as a 0, and I could, instead of describing a function with x-intercepts, I can just call them zeros. And those are the x values in which it crosses the x-axis. And I want to hear from you, what is an even function similar to? Right, so we're talking in the realm of symmetry, so how does an even function relate to that? And same with an odd function. In terms of symmetry, how does that odd function relate? So this does conclude our lesson. If you have any other questions, please leave them in the comments.